Welcome to Black Hat Briefings, held November 21st through the 22nd, 2001 in Amsterdam. This is videotape number 8, Active Directory and Group Policy.
Thank you for all attending. My name is Raymond Forbes. We're going to be talking about Active Directory and Group Policy. To give you a little background on me, I don't know how many people have been to Black Hats before, but I've spoken at several of these, usually under a rooster. Currently, right now, I'm employed at Microsoft as a security architect. Originally was hired as pet hacker for online operations, MSN, Passport, Hotmail. Now I'm basically doing architect work on the infrastructure itself. One of my roles being the security representative for Active Directory, and using group policy specifically for creating an IPsec infrastructure. And we're going to go over basically how Active Directory works and how group policy interacts with it. We're going to talk about the structures and the components, how objects interact, how the roles, the schema, sites, interoperability with other operating systems. So the first step is, what is an Active Directory? Active Directory is an LDAP Directory Service, plain and simple. LDAP, as I'm sure many are familiar, could be considered X500 light. Somebody decided the X500 protocol was a bit too heavy, so they narrowed it down and made it LDAP. Active Directory is actually incorporated and requires DNS. It doesn't require Microsoft DNS, but it does require a DNS, and it has to be at least a bind 495, but preferably an 8. It has to be able to support SRV records and the such. And if you want to use the full benefit of it, it has to support dynamic updates. It's incorporated into Windows 2000 and into XP. It's centrally managed. Basically, it's the central management point for anything that if you want to centrally manage your Windows 2000 infrastructure, this is the way it happens. It's extensible, meaning that a third-party application doesn't need to rewrite a directory service on top of your infrastructure. You can basically just extend the infrastructure that it exists through the schema, and we're going to talk a little bit about that. And it's interoperable. I know, for instance, interoperable with NIS. I'm not sure about NDS. I've never really actually seen that, but I know it works with NIS. So what makes up Active Directory? The key fundamental issue of Active Directory is objects. Active Directory is, I guess, an extension of the object-oriented design. Everything that you see within Active Directory is considered an object, whether it be a user, a machine, a printer, any kind of thing you're accessing is going to be an object. It's going to have attributes, which you could, if you're an object-oriented programmer, you could consider the methods. Sites. It's made up of sites, which are basically just collections of your subnets, your IP addresses. It's made up of domains, trees, and forests. The idea being that a tree is a collection of domains. So you create a domain, say blackhat.com, and then you create subdomains and of, say, east.blackhat.com or west, and multiple trees live inside a forest. And I'll have a picture of that in a little bit. And we have multiple kinds of trusts. In old school NT4 days, you had the one kind of trust. You had what was considered a one-way trust relationship. And if you wanted to create a two-way trust relationship between multiple domains, you had to create each one by hand. Well, Windows 2000 took the Kerberos approach to trust concepts. And you have what's called a transitive trust, which means it's by default a trust relationship between a domain and its child domain are considered two-way transitive. And I'll show what that means. And a cross-link, which is basically a shortcut trust. You have domain controllers, and you have your groups. I'm sure many are familiar with the global groups and the local groups, but there's another group, which is called the universal group, which basically means it incorporates users from many domains. Okay, so this is a very basic Active Directory infrastructure. You have your domain, and you have what's called organizational units. Now, the easiest way to think about organizational units is they are an administration concept. They're nothing more than a way to group objects, be it machines or be it users. Here we have a tree. As you can see here, a two-way trust is established on each side of the tree. We have west.blackhat.com and east.blackhat.com. And then what you see the dotted line here, this is the transitive trust, which basically means since west trusts blackhat.com and east trusts blackhat.com, west trusts east and east trusts west. Now, like I said, this is the way Kerberos handles trusts, but it's something you should be aware of when you're setting up trust relationships, that you'll notice, like you'll be trying to log into a machine that exists in east. You pull down the drop-down menu of all the different domains you can log into. You'll see west and you'll see blackhat.com. Here we see a forest. And the point of this forest was two things. When you establish a trust relationship between two trees in a forest, by default, it is a one-way, non-transitive trust. And the other point of this one was to bring out what a cross-link trust is. Now, the way authentication happens within this domain, I'm over here in domain right, and I actually try to use my transitive trust to authenticate against this one. The way it works is I actually send my request up to blackhat.com, which then passes the request back down. And you can see there's a little bit of extra traffic, a little bit extra delay. Depending on your environment, you may want to create what's called a cross-link trust. And a trust is established between these two domains. So the traffic isn't passed up through blackhat.com, it's directly handed over to the west. Okay, what is a site? Sites are collections of IP addresses. It's pretty straightforward. They're subnets that you've established. And basically, the main point of a site is to establish a physical description of your environment. The concept of domains is more of a political or more of a more ideological type of view of it. And the idea is that it should be able to span geographical areas. And then you can have sites to establish policies based on geographical areas. For instance, maybe you have an office in Asia that for some reason there's a law they can't view certain websites. Well, you can apply a policy onto the Asia site itself to block something without actually having to drop it onto their domain, which would affect more than just Asia. The other thing that it's used for is replication. It's very important for replication. It's what it handles the intra-site replication, and inside the site you create your bridgehead server so that when you have inter-site communication going on, it's handled there. It's also used at logon to find the closest domain controller. One thing to know about sites is that the subnet, the subnets are basically manually entered by you. So they don't necessarily have to conform to whatever your subnetting environment is like on your network. The tool that it uses within the site itself to determine how the replication is going to happen is called the knowledge consistency checker. It's just a tiny little automatic tool. It goes through your environment and determines how the replication topology is going to happen. It's also going to determine your bridgehead servers. Although, this is something that can be gone through and set manually. Okay, so Active Directory does not have a concept of a primary domain controller and backup domain controllers. It is a multi-master environment, which basically means changes can happen on any one of the domain controllers. Nothing takes precedence. So the question is, how do you handle conflicts? How do you deal with replication correctly? What if changes happen on multiple boxes? And a lot of this is where the FSMO rules come in. The first FSMO rule is your domain naming master. Basically, as a background on this. What a role is a responsibility that a particular domain controller takes. These are configurable within Active Directory, specifically within the sites and services snap-in. But each one of these roles has to be maintained. So the domain naming master, its role is to hold specific information about what domains and what domains and what sites and what trees exist in the forest. That's its only role. So if a domain is deleted, if a tree is deleted, or anything is deleted like that, it's sent specifically to here. And this is the only one that holds the information. The infrastructure master. The infrastructure master specifically holds information about cross-domain, or cross-tree, cross-forest information. In the old days of NT4, if you were to say, wanted to move an account from one domain to another domain, you would have to effectively delete the account and then rebuild the account somewhere else, which was kind of a headache, because what that meant is any kind of permissions or anything like that, you had to redo those permissions again. Well, under Windows 2000, that's not the case. It actually attaches the SID, moves that account over, and actually has that SID as a secondary SID onto that account, which means any permissions that a user had when they moved, they still have. All that information is maintained by the infrastructure master. Now, that's something to think about, because if the reason why they're moving domains is because they've changed roles within the company. Say they were in HR, they're no longer in HR, they're in manufacturing. Obviously, you want to make sure that they don't have access to that information that they had before. PDC emulator. The PDC emulator is one of the main roles it has is to support NT4 backup domain controllers. It is possible within Windows 2000 mixed environment to have domain controllers that are NT4. The problem is they don't understand the concept of mixed master. The PDC emulator actually takes the role of the PDC and announces itself in such a way. Now, later on, we'll also learn that it does a couple of other important tasks. So even though you don't have, say you start up the Windows 2000 Active Directory and you do not install NT4 and you only have Windows 2000, you will still have a PDC emulator because it handles some important issues with passwords and such. We'll talk about those in a second. There's a relative ID master, or the RID master. Basically what that does is it makes sure that the RID, or the SID that is established for each object that's created, a policy object, a group object, a user, any such object, is unique globally throughout the infrastructure. And then there's the schema master. Specifically, what a schema master does is it holds a schema for the entire forest. Why this is important, and there's only one schema for the forest, and why that is important is you cannot extend a schema for one domain. That if you extend a schema, it actually affects the entire forest. The only way around this is to create multiple forests. I believe one of the main differences in XP is that that is not true. They've moved away from the schema being attached to the forest itself. And then there's the global catalog. What the global catalog server does is it establishes a quick, small, read-only version of the schema data of the entire schema. It has information that maybe you've said, like for instance, if you think that phone numbers are going to be accessed a lot in your environment, you can make that part of the global catalog. That way, people searching for those, the searches will be faster. It's actually necessary for logons. This is a tricky one. How many people here actually have an Active Directory infrastructure where you're working? Wow, very few. When you do this, you want to make sure that the server that is your global catalog does not go offline. Basically what happens if you lose your global catalog, you can't log into the network anymore. And of course, it doesn't give any like really cool error messages like global catalog is down. It says can't connect to the network, logging on with cached information, which is useless, and it took me about 2 days to figure out why nobody could log on. So it's very important. Okay, so what exactly is the schema? Schema specifically holds what type of information can actually be stored in Active Directory. You could call it the skeleton of Active Directory. The schema is built on classes. And what a class is a description of what an object can be. For instance, you might have a user class. And that user class, when you create a user, it goes to the user class, pulls out the information of what a user object can look like, and then creates a user object. Attributes are actually defined for classes. You have optional class, you have optional, and you have mandatory. For a user, for instance, mandatory is a SID and a name. Optional is everything. In fact, and like I said, this is extensible. You could go and say your user class, and you could make a password mandatory. The schema itself is built in a tree-like structure. You have the root of your schema, and it flows down, which means that the classes are inherited. Say you were to have a user class, and underneath that you had created an admin user class and a manufacturing user class. All the attributes that you had defined inside of the user class will then be applied also to the manufacturing and also the admin. So, the kind of classes that make up a schema. You have abstract classes. Abstract classes are what the skeleton of the schema itself. They define the schema. They're not actually used to make objects. They just provide that structure. The structural classes are what actually define objects. These are, you have, like I said, the user class. You might have a machine class. Many different kinds of classes. This is how they're made. You'll see a class with these attributes defined for each one. And then you have auxiliary classes. What an auxiliary class is for is to provide additional attributes to any class that you want. For instance, a security identifier is a auxiliary class. And what that means is you can attach additional security options or attributes to any type of object you want. Schema is cached in memory. As I said before, only one schema for the entire forest. The other important information is that when you create a new class in the schema, you can't actually delete it. Nothing is deletable from there. The best you can do is deactivate it. Not probably a problem if you make one or two classes, but it can actually affect performance because it is loaded into memory, the whole thing. I threw this in here so that I could talk for a second about what happens to your DNS servers. Now, this hit me when I actually had my home servers, when I set up my home network with Active Directory, and then my friend who was my secondary was running NT4, and I effectively blew up his DNS server. And it was because it started passing down all kinds of crap that it uses for how it locates things, which NT4 could not handle. So that's why you have to make sure that whatever DNS servers are your secondaries for these things have to be able to handle things like SRV records. And it puts a lot of them in there, and it puts keys in there, and it's quite interesting. Kerberos information. Okay. So let's talk about replication. As I said, replication is multi-mastered. So the question is, how does it keep track of that information? How does it know changes are being handled effectively? the way this works is it tracks metadata, or data of data, meaning that it keeps pertinent information about the changes that are made and uses that to determine when a change is valid. Replication is actually different when it's based on whether it's on an intra-site or inter-site. As you could see, as I guess would be obvious, the concept of a site is where it is physically located. So if the reason why you have sites is you have a slow network link between, say, an office in Denmark as opposed to your office in Seattle, and you're running a 128K link between those, you don't want to have the only traffic being allowed across that being your Active Directory replication, and it can do it. So intra-site is simple, it's not configurable, it just blasts right through it. Data just goes out, doesn't matter where it's going. Inter-site, on the other hand, uses things like bridgehead servers to determine how the replication happens. Choke points, you schedule it, you say I'd like it to happen from 10 o'clock at night to 11 o'clock at night. Everything's defined. Down to the point that you can actually use SMTP, which is a much lighter protocol than RPC. The only problem with that is not everything, I think I mentioned it later as well, but basically when you use SMTP, it doesn't do file. So if you have logon scripts that you changed, it will not be transferred over SMTP. Not all data is replicated. The key one is last logon time. If you're actually making a query to find out when the last time a user is logged on, you're actually ended up querying every one of the domain controllers, because that information does not get replicated out. It replicates attributes, not entire objects. So, for instance, if you change your password, it doesn't replicate your entire user object throughout the thing. It replicates just that attribute change, your password. Okay, so what is the metadata that it keeps track of to determine how changes were kept? So the first thing that it keeps is the update sequence number. This is defined on the server, on the Active Directory. It keeps track of everybody else's, all the other directories' sequence number. It keeps a property version number. This is actually the version of the attribute. And it keeps an IP address of the domain controller. Or wait, that's just, never mind. Let's see what I say here. Okay, so the way this works, inside the Active Directory, it establishes a small database of servers and their update sequence number. And so when a server makes a change, it announces out to everybody, I've got a change to make. Well, the server then replies back and says, I have you at update sequence number 95. Could you please provide me everything that you've got since then? Well, the server's up to 97. So it then hands back, these are the two, the changes that I've got from this point. It then takes the changes, applies the changes, updates the update sequence number of the server, and then goes on. And at that point, if it has any servers it's responsible for, it will then announce out to them, I have a change that you need to take care of. So the question is, what happens if you make a change on two different servers? Which one takes effect? So what it does is it compares the property value number. This is the version of the attribute. It looks at the change and it looks at the version number. If they're different, if the change is actually lower, it will throw the change away. If they're the same, but the attribute is different, that's where the confusion comes in. So the first thing that it looks at is which one has the highest property value number, which one has the highest attribute. If they're the same, then the change is different. It moves on. What is the timestamp? Which one happened latest? The one that happened latest is going to take precedence, and the other one will be thrown away. But what if they were done at the exact same time? Now, it seems kind of ridiculous that it would be possible to make a change at the exact same time, at the exact same instance, on 2 different servers. And I would imagine it probably would happen almost never. But in case it does, the next thing we'll look is at the IP address. Now this is kind of conflicting because I've read Microsoft documentation that says it'll look at the GUID. But it doesn't really matter. It looks at the unique number of the server. Whichever one is higher, that's the change it takes. Kind of arbitrary, but I guess it gets the job done. Oops. Inter-site replication. So let's talk about this for a minute. This is, as I said, is the low bandwidth method of replication. By default, it's done on a schedule. The schedule is configurable within Active Directory, within sites and services. It's quite configurable. You can define what servers replicate to what servers and what data gets replicated at what time. As I said, you can use RPC or SMTP, and before, you can't replicate things like logon scripts. So if you make those changes, you won't be able to use SMTP. It actually compresses the data by up to 15% as it goes across the link. The difference is that what you can do is you can turn on what's called inter-site notification. The notification process is exactly as I described. That's where the server announces I've made a change and asks for it to then be picked up. You can turn on inter-site replication to happen exactly that way, that there isn't a schedule, that it waits for an instant notification. Okay, so password changes. This is the one that gets a little tricky. For instance, if you make a password change, one thing to remember is that replication happens every 5 minutes and then 30 minutes for an actual server. It's not actually instantaneous. So for instance, if I change a password on one controller, it could take effectively as long as 90 minutes for that change to replicate throughout the environment. How then do I make sure that I can still log on, within that window? So the way this is done is with the PDC emulator. This is why you still need it even though you don't have an NT4 environment. The password is changed on the DC and is actually immediately pushed up to the PDC emulator. So it has the information immediately. And if you try to log into a domain controller and you give it a pad password, what it does at that point is it then takes that password and hands it to the PDC emulator. It does this to make sure that it was not changed recently. Okay, so there are other problems that derive from replication. Some attributes have multiple values. For instance, a group, its value the attribute is users, and its value is user 1, user 2, user 3. So what happens when you add a user from one group? Let's say you just add a user on one controller and somebody else adds a user on another controller. 2 different users added to the same group. So what's going to happen is that when the update goes out, it's going to look at that property value number. It's going to see the same property value number. And once again, it'll look at timestamp and it'll see different changes. What it will actually do is it will drop the latest. It will only keep the latest change. You will lose that second attribute. So you would have to go through and re-add that user again. Inherited permissions, meaning if you, like in your registry or in the directories, when you actually say, please apply all permissions to be inheritable, and it goes down through all the child trees. Each an inheritable permission is actually stored in each object, which means that when you apply it, when you apply that inheritable permission, that security identifier is attached to each one of the children. It's not actually just stored in the parent. But Active Directory does not replicate that change as a huge, massive amounts of directory changes. It passes the one tree across saying, okay, I've got an inheritable permission that I'm passing across. It takes just the one permission, says it's inheritable, drops it on the server, and at that point, it does the inheritance. Next replication issue. You delete an object, except you don't tell the other domain. You can't just delete an object because the other domain controllers don't know it's supposed to be deleted. Just because it's gone does not represent something as understanding that it's supposed to be deleted. So instead of deleting it, you add what's called a tombstone. Now, people who are familiar with databases and other replications, I'm sure, are familiar with the concept of tombstones. You put the tombstone on the object, and it becomes deactivated. It's hidden, put in the deleted objects container, and at that point, it's hidden from everything, including ADSI. So you wouldn't be able to even script through the scripting engine to be able to reach this thing. The tombstone is then replicated to all controllers, and after every day, there's what's called garbage collection. Goes through once, looks at each tombstone, sees if it's expired, and then yanks it if it has. There's something called the lost and found container. So lost and found container happens when replication tries to happen, and it tries to update an attribute, and for some reason it can't update it. A good example of this would be if you try to add a user to an organizational unit, but from another domain you actually deleted the organizational unit, you're going to have this replication floating around that it doesn't know how to handle. So it drops into lost and found. Lost and found is actually a container that you need to go in and clean out. Okay, so they call intra-site replication instant, but in reality it's not instant. It happens, what does it say here? It happens every 5 minutes, for the intra-site, and of course on schedule on intra-site. But certain things actually need real instant replication. That 5-minute delay is unacceptable. Those examples are the RID master. If you change your RID master, that has to be replicated instantly. Otherwise, objects can't be created, or if they're being created ineffectively. LSA secret change, that doesn't really come into play. And account lockouts for obvious reasons. If you lock out an account on one domain controller, you want to make sure that it's locked out on all domain controllers. You don't want them to be able to move at that point to try to authenticate against another one. Okay, so urgent replication will not happen inter-site unless you actually turn on the notification. All right, let's see here. Now, one problem that we're going to have here is that these slides didn't make it in your books. And I apologize, I'm not sure exactly what happened, but I have all my group policy slides here that aren't in your books. So, group policy. Group policy is the centralized management system for applying policies across your Active Directory infrastructure. You can think of a group policy is made up of group policy objects. And an object is nothing more than a collection of policies. And we're talking about things like, how often a password has to be changed, whether a person can log onto a box, to how your log files are stored. These are all policies. It replaces system policy. Has anybody here used system policy before? It came with NT4. I never used it either. It didn't seem like it worked all that well. It requires Win2K in Active Directory. And it actually defines two different kinds of policies, a user policy and a computer policy. Okay, so there are sets of policies. There is the local policy. And this is what you see when you bring up the local security policies, or if you bring up the group policy snap-in and point it to your local machine. What you're actually looking at is your local policies. And these are machine specific. There's the default policy. And what the default policy is is when you turn on the box, when you install Windows 2000 and you turn on the box, it's what's the policy that's on the box at the time and then throughout your domain. There's the group policy objects, and this is what we're going to be talking about. And then there's the NT system policy. So the different kinds of things that group policy can do, it can lock down your desktop, it can install software, it can run scripts, both for the user, meaning log on and log off scripts, or it can actually do computers, startup, shutdown scripts. You can use it to configure some of your components, Windows Explorer or Internet Explorer, media player is another one you can configure, and you can do things like redirect folders. So, when you actually create a group policy object, where is it actually physically located? So, when you first install Active Directory, it asks you where you want to put what's called the Sysvol directory. This is where it stores all of its actual data information. And this is no exception. When you create a group policy object, it actually creates a folder inside the Sysvol directory on the DC itself. And it's called the group policy template directory. It's made up of the GUID of the group policy object itself. Inside that directory, you have the ADM files, which are the actual template files that are used to, when applied, tell the system what policies you want applied. Whatever scripts you have, the log on, log off for startup or shutdown scripts all exist within that directory. And your user files, files or folders. For instance, if any of the policies actually make registry changes, it makes a file called the registry.pol file. You can use it to apply security settings, which is really, to me, the most important aspect. You can use it to change registry settings and security and change file system security settings. What I actually use this for specifically is changing the file system. If you actually bring up the file system and you look at it, the file system allows the C root to be read by everyone. Everyone has full control of the C root directory, which, of course, is a big problem with IIS servers. Because if any of you have ever been affected by a directory transversal bug, which is basically the iUser account having the ability to run things like cmd.exe. Well, by turning off this everyone ability to read the C drive or have full control of it even, and make it so only authenticated users can do it, you can actually prevent this. Now, that takes some testing, because at the same time on our web server, if we were going to make only authenticated users being able to access our C drive, it would not allow ASP pages to run, because there's a DLL that exists that actually needs to be instantiated by iUser. But there's definitely things you can do within this within the file system change to lock yourself down. So where do we apply group policy? One of the places we can apply it is on a site level. This is good for things that affect local environments. It will actually can affect multiple domains, because as I said, domains and sites are not congruous. They can exist inter of each other. The problem is, or I wouldn't say necessarily a problem, but the thing to realize is if I apply a policy to a site and I applied that while I was connected to a domain controller in, say, domain A, that policy exists on domain A, even though it is applied to the site. Now, if I, as a user, log into a machine on domain B, if that group policy applies to me, I will have to connect to the domain controller in domain A to actually pull that group policy object down. We can apply it on domain. One important thing here to understand is that there are certain policies that can only be applied on domains. The important ones are your account policies, passwords, account lockouts, and Kerberos. Now, the thing that's important to realize here is it won't tell you if you try to apply it across site or organizational unit that it won't allow it. It will only ignore it. So let's say you decided you wanted to change things on an organizational level. You make some password changes on an organizational level. Those are going to be completely ignored. You have to apply this on the domain. So the most tricky thing about group policy that I found is how to realize what policies are actually being applied. And the question comes up, in what order does it apply it? If I have, for instance, I've created my password policy and I've thrown in some other policies and I apply it to my domain, or I link it to my domain as the term is called. But then I create another one and then I link it to my site. And the guy that runs the organizational unit, well, he had created a group policy object as well, and he linked it to his OU. What if those policies conflict with each other? What if he makes something, a registry change, that changes what I've already done? What if he says things like he changes logging policies and he actually makes it lighter logging? What takes precedence? The way it works is that the first thing it applies is the local security policy. It applies a local security policy across the computer. The next is the site, which means that if there's anything in the site that's different than on the local security policy, it will be changed. That site will take precedence over local security policy. The next thing will be done is domain, and the same step ensues. If there is any change within the domain or if there's anything different in domain from site, domain will take precedence. And then there's OU. OU takes the most precedence. Anything that's actually been changed in OU will take precedence over the other three. So, but there are ways, okay, so at this point, when you look at a computer and it's booting up, this is the exact process it makes coming in. The computer reaches the DC to the domain controller, pulls down its GPO. This includes any of the domain controllers it has to connect to actually pull site-specific information down, as I said. So you might be contacting multiple domain controllers. The computer policies are applied in the order that we discussed: local, site, domain, OU. And then the startup scripts are executed. The user logs on at this point, and then the user profiles are loaded. And at this point, it contacts the DCs once again and goes through that same process that I went through for the computers. Policies are applied based on the order discussed, and then the user logon scripts happen. And then when you log off, obviously the user log off scripts are then executed. Now within this, as many people who've logged into a Win2K machine have seen, you see that the little dialog box that says applying security policies. Now, and it shows that you have to wait. You have to actually wait till everything's applied, and then it will allow you to log on. That's called synchronous. Basically means all the policies have to be applied to the system before you're actually allowed to log on. Now, there is something called asynchronous, and amazingly enough, Microsoft does not recommend that you use asynchronous, synchronous or processing. And what that means is it will actually allow you to log on while it's processing the policy object. Now, this makes it quicker. Obviously, you're able to log on right away. But this is a problem security-wise. For instance, if what your group policy is doing is locking down the desktop, maybe making the run menu unavailable, it will all be available while the asynchronous is happening. So for a short period of time, you will actually be able to, you'll have more access than you're supposed to be allowed to. These are all policies that are actually set in group policy. So group policy itself is what's used to actually configure group policy. So they've created what's called exceptions. What exceptions do is, for instance, if I don't want my policy to be blocked. For instance, I set some policies on the domain, and I don't want those changes to be taken. You can block inherit or no override, which basically means that, well, let's go the other way around. You can block inheritance. If I set a local security policy and I like it the way it is, well, you can't really do the local security policy, it's a bad example. If I set a domain I can set up to make so that any changes that are made lower level can't actually change it. And that's called block inheritance. The other function is if I don't want that inheritance to be blocked, I can make no override, which means that the block inheritance will keep from working. And then also at the same time, you could specify with permissions. And this is interesting. What this basically means is that the way the group policy works is it works just like any other objects. It has permissions assigned to it. You go into the group policy and you go into the security aspect of it, and you will see all the different groups that have access to it. You could actually effectively go in there and remove a certain group's read and execute access to this, and this group policy will not be applied to that group. So for instance, say you have yourself a domain and you're applying a password policy to it that says if you change your you can't change your password more than, like every day, you have to wait a day before you're allowed to change your password again. But you don't want this to be applied to the administrators. There's two things you could do. You could create an organizational unit for those users, drop your users in there, and then apply the policy to the normal user organizational unit, or you can do it this way. In your administrators group, you can deny them access to that policy, and that policy won't take effect. Okay, refresh. In the old days of NT4 with the system policies, when a policy was applied to a system, if a change was made, it would never actually be updated in the system. You had to actually log off and log back onto the machine to have that policy applied. This isn't true with the group policy. On a domain controller, every 5 minutes, it checks to see if a policy change was made and whether it should apply it. On normal machines, it's actually every 90 minutes with a 30-minute offset. The reason for that is you basically don't want every machine waking up and checking for a policy update at the same time. So this creates a much more random environment for that. Not everything refreshes. Folder redirection is a good example of this. You have problems with file lock. You try to redirect a file in another direction with a file lock going and it won't work. Okay, so there are different aspects of group policy objects you're actually able to delegate. You can delegate whether you're even allowed to edit a GPO or a group policy object, and you can delegate whether whether you can actually apply that group policy object to a domain or an organizational unit. These are permissions there's actually a link GPO type permission when you build an organizational unit or a domain or even site. It's possible, in fact, it happens a lot, where you can actually link the same group policy object to multiple domains or organizational units. You build the group policy object within one domain, that object is now available to you across the board. So when you go to another domain, you try to link a policy object, you can grab that. GPOs exist on the domain. They don't actually replicate between domains. This is important because you can actually use a GPO from another domain. You can browse a network, you browse to that other domain, and you choose its GPO. Now, this can cause traffic problems because a group policy object can be quite large. As I said, there's two types of configurations. There's computer configuration and there's user configuration. They're pretty similar. For instance, software installation. You'll look inside there and they look about the same for the both. It's just about when it's applied. Windows settings a little different. Inside the Windows settings, inside of user, you'll see the actual log on, log off scripts. But inside of the computer, you'll see the shutdown and startup scripts. Security settings. Security settings are completely different. The security settings that are important to you or when you're applying security across your environment, things like password, how your Kerberos policies are maintained, your logging, all happen within the computer configuration. Inside user is more things like your PKI environment. Now, you also have IPsec policies that are applied to, that are on both user and computer. Administrative templates. This is where the more administrative configuration happens, and it's kind of a silly name to call them templates because it's actually the changes are actually here. This is where things like, what would be here? Your group policy changes are in here. That's under computer management. And the last thing we'll talk about is restricted groups. Restricted groups was kind of a cool idea. Basically what a restricted group is you define, we'll say the administrators group. You call the administrators group a restricted group. And then in there, you define what users are allowed to be in the restricted group or what users are not allowed to be in this restricted group. Which means that it'll actually check the group and compare it against the restricted group. And if it finds one that's not supposed to be in there, or that is not in there when it's supposed to be in there, it will take that action of either removing or adding it. This is great for the administrators group because if somebody figures out how to make privilege escalations and adds themselves to the administrators group, this gets run and yanks them back out of it. And the last thing it does is defines what groups the restricted group should be part of. And I don't generally call my restricted group she's. I'm not sure why that was like that. And that pretty much covers it. I was going to try to do a demo, but unfortunately my Win2K box blew up. So is there any questions about the Active Directory or the group policy that we talked about?
At the beginning you talked about all these different domain naming master, construction master.
Right.
Are each one of those things a single point of failure for the functionality they provide?
Yes.
Is that per site or across the entire forest?
Across the entire forest, depending on the role. Most of those are across the entire forest. Those are easily changed. But yes, they are single. Like your global catalog is a single point of failure, which is why I say it's very important to make sure you have that up.
Can you cluster a machine to provide some sort of reliability for that?
You can't. I don't think you can really use clustering with it. I think that would confuse it. I've never tried it. I would imagine that it would get confused.
So you have to have a single machine which holds your global catalog. If that machine goes down,
Yes.
you can't do logins. Anything that requires that global catalog is stuck.
Right. Although the global catalog can be rebuilt quite effectively, but like if it goes down, you can choose another machine as your global catalog, and that will resolve that.
So following on from that, if you lose a network connection to your HQ site, does that mean that people in outlying sites wouldn't be able to log on?
If that's where your only global catalog was, then yeah. What you'll see, in fact, that's an interesting question. The recommendation is you have a global catalog on each site to prevent that from happening.
I have a couple questions actually. Given the population of all sorts of information into the DNS, are you recommending that people use split DNS now?
Using what?
Using split DNS, having one DNS server inside?
Oh, well, to be honest, I've always done that. So I
Well, it's a good idea in general, but this raises the stakes.
it does because it kind of shares a bit too much information, especially since it has keys and things like that. But I've always recommended having split DNS, so it's kind of hard for me to say this really does it.
And there was on one of your slides when you're talking about the GPOs getting crossing the format, it said that they were removed and logged off.
Oh, yes, right.
The example that you used was changing the ACLs on C root.
Mm-hmm.
Would that mean that ACL would go away if there was a user logged into the console?
Depending on how you have it set up. If it's set up through user, then yes. If it's set up through computer, then no. So.
That was okay. And last question. On the order of process, if there's a no override set at a higher level, does that prevent an administrator from making more secure policy settings on something that's further down?
Yes, it can, which is what the block, or it's the other way around. If the block inheritance is set, it can keep from the higher level administrator from setting more secure settings, which is why you have the no override. to prevent that from happening.
Yeah, it goes either way, right?
Right. So.
Yeah, I have another question regarding DNS. What can you do when you DNS proofs? And also, more generally, how do you deal with rogue machines that do not comply to what they should do and policies that they should apply that they don't?
Let's start with the DNS question. How do we deal with DNS spoofing? Is that the question? So beyond the fact that really the best thing is any DNS server that you use should have cache protection on it. But I wouldn't say there's any special thing with Active Directory other than it's a little harder to spoof secure DNS with the way the keys are set up. But there's nothing special about it to actually prevent or do anything with DNS spoofing. What was the other question?
About how you deal with machines that do not comply to what they should do.
Meaning?
Say you have to, the group policy says the local machine has to apply a certain policy, and the machine doesn't apply it. So,
How would it not apply it?
I don't know, maybe there's a hack in the...
Oh, like it tried to apply it and it couldn't apply it, it'll fail. And I've never actually seen that happen where a group policy couldn't be applied. I mean, honestly, I can't think of a circumstance where that would happen.
Or you mentioned that a user should not, for instance, say a user should not be allowed to access a certain menu.
Right.
And say the machine, through some hack, doesn't apply this policy. So,
Well, I mean, I haven't seen that. I'm not sure how that it would handle that because I've never seen that happen. My guess is that it would fail, that it would actually report an error saying that it couldn't apply this policy for some unknown error. I mean, it will say that, yeah?
Well, the machine itself has to go out and request the policy item.
Right. I mean, you're assuming that the machine went out.
You could block that request in a number of ways,
Yep.
and so that it wouldn't be requesting your policy item to never apply.
Right. I'm more going from the, if I've got the policy and I try to apply it and it fails to apply, and it's going to make an error. If the guy who set up the hack didn't do a very good job, it's going to throw an error.
So we have an active directory, and last week the administrators could no more log in locally on the domain controller suddenly. When you have such a problem, from where do you start the troubleshooting?
Well, logs usually. Did it say, do you know what the error was?
Sorry?
Do you know what the error was?
No, the person with administrating directory said he hasn't changed anything, and suddenly he came back for another reason.
Well, for instance, one reason you won't be able to log on to a Windows 2000 box in an environment like that is your time is off. Because Kerberos is based on time. If you fall away from that 5-minute time period, it won't allow you to log on. But other than that, other than trying to troubleshoot something like that, it's really based on the logs. And the logs will say specifically why people are being rejected. Any other questions? Okay, well, thank you very much. If you have anything further, you can mail me at rooster@attrition.org. I'm more than happy to answer any questions.